All right, so here's some more interesting theorems we can think about. This first one says, in a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord in its arc. Similarly, we're just going to cover these at the same time. In a circle, the perpendicular bisector of a chord is a radius or diameter. So what this is basically saying is, if we have a circle, we'll just use this circle. So if we have a circle right here, and we draw 2 points on it to create a chord, it doesn't matter where you draw it. If we have a chord here, wherever we bisect that chord is going to be a radius, and wherever we can fit a radius perpendicularly to the chord, these sides are going to be equal. So whenever we can draw a radius perpendicular to a chord, we know that we can split the chord right in half. So we'll see how we can use information like this to actually solve things. So if we know that this is the case, and we've got this down here, we're on example 4. We've got RM, NS, SP, a bunch of different not angles, but side measurements and things like that. And we're trying to find NP. So we're trying to find this whole thing. So what we should do, what I think, first of all, we know that these are the same thing. So NP is going to be equal to 2 times SP, or 2 times NS. And so if we can find one of those, we can find what the total length is. So what I'm going to do is I'm going to utilize the information that we have about this triangle here. And I'm going to redraw this triangle out here. And we'll see that this is 8, right? We don't know what this is, and we don't know what this is. However, we do know something about the radiuses, right? Once again, sorry about that awkward pause. So we know that if the radius from this center to the outside is 17, let's look at our triangle and see if we have any other radiuses, or radii. And it looks like we do, right? The line we created from R to P, that's going to be a radius as well. And so we know that that length is going to be 17. So what we can do with this is our favorite old Pythagorean theorem. So we're going to have 17 squared equals 8 squared plus NP squared. So we end up with the square root of 17 squared minus 8 squared, which when we type that into our calculator, beep boop bop boop boop, we end up with 15. So NP equals 15. And we know that, NP does not equal 15. That's not what we're trying to find. SP equals 15. And NP is 2 of those. So NP equals 30. Okay, so there's that. That's how we can use these to solve equations and solve problems. It takes a little intuition, which is my favorite thing to watch you guys do. So feel free to practice this, and I think we're just going to go over 11.3, and then we're going to be done with the module.